Here's an outline of the technique for using the annihilator method. Find our complementary solution, which is the solution of the homogeneous equation, linear differential operator applied to y equals 0. Operate on both sides of the non-homogeneous equation with an annihilator L1 that annihilates the g of x also. So we annihilate on both sides to get rid of the g of x. Then we have this linear operator applied to our linear operator and equals 0, so we have a homogeneous equation. Delete from the solution of the equation all duplicates that are in yc and form a linear combination yp of all the remaining terms that weren't part of the complementary solution. This is the form or the particular solution to L of y equals g of x, the non-homogeneous equation. And then we need the actual coefficients, so we substitute this yp and all required derivatives into the original equation and solve for the coefficients, thus finding our yp. And of course the solution is the complementary solution plus the particular solution. So without further ado, let's go right into solving an equation. This one might be a difficult one.
Ooh, that's hard.
But let's make a stab at it anyway. So here we got y third derivative plus 4 times y first derivative equals e to the x times cosine of 2x. Well, first of all, the characteristic equation m cubed plus 4m equals 0. And we find m equals 0 and plus or minus 2i are the solutions. So the solution of the homogeneous equation, we got our yc, c1 from 0. That's c1 times e to the 0, but that's 1. So plus c2 cosine of 2x plus c3 sine of 2x, that's from the plus or minus 2i part. So the equation in annihilator form now looks like this: d cubed plus 4d, that's this side, applied to y equals e to the x times cosine of 2x. So to annihilate the right side, to annihilate this, we need to apply, see, a is 1, b is 2, so 1 squared plus 2 squared is 5, and a is 1, so 2 times 1 times d, so we need this operator applied to both sides of the equation. Of course, apply it to the right side, we get 0. Apply it to the left side, look what we get all this. So, now what?
We better put on our thinking caps and think hard.
Yes, we better. So, this annihilator equal to 0 would have this solution, this solution, this solution, that comes from this part. And from this part, we would get a times e to the x cosine of 2x plus b times e to the x times sine of 2x. That's from this part, right? And so this part of it, of course, is the solution to the homogeneous equation. So this is what we're going to focus on as our yp. So let's see what happens. Our yp, therefore, is a times e to the x cosine of 2x plus b times e to the x sine of 2x. And here's where the manipulations get deep.
Ooh, this is fun.
Well, okay, what we have to do first is take a derivative of this, because we're going to have to substitute y cubed, or sorry, third derivative of yp back into the equation. So, here's yp. Here's its first derivative. Derivative of cosine of 2x is negative 2 times sine of 2x, so the derivative of this term, first d second plus second d first, so negative 2a e to the x sine of 2x plus positive a e to the x cosine of 2x. And then the derivative of this term, in a similar fashion, 2b e to the x cosine 2x plus b e to the x sine of 2x. Or more simply, nice to simplify this if at all possible, b minus 2a times e to the x sine of 2x, that's collecting up this term and this term, plus a plus 2b, that's collecting up this term and this term, times e to the x cosine of 2x. Now, it was nice to do that because that's going to make finding the second derivative a bit easier. So here's the second derivative. Maybe you would take my word for it, but first, that's all this, d second. So there we have it. That's all of that. Whoops, sorry, that's too much to here. That's all. Oh, it looks like I can't show you. It's from here over to here. And then plus second d first, that's sine of 2x times the derivative of this, which is just this. So, and that's, here it is factored out of that. So, and similarly, this is the derivative of this part. That's our second derivative. But you know, this one, oh, and here's our second derivative, somewhat simplified. But we're going to need, for this one, we are going to need a third derivative. By the way, I collected up the like terms, but you can trust me, this is just an algebra move. So one more painful differentiation, we need a, dare I say it, we need a third derivative. And I'll be honest with this one, I think I probably used my software and came up with this as the third derivative. And now we can painfully substitute this back into the original equation.
So very difficult.
Yes, but we must do this. So we're going to put that third derivative back in here and the first derivative in here. Here's the third derivative plus 4 times, where's my 4? Four times, there we go, the second derivative. Oh dear, that's not big enough. Okay, this will have to be a 4 over here also. All right, all of that is equal to e to the x cosine of x. So, what does this mean? Okay, I fixed my errors. So anyway, when we get back to this painful substitution, this is pretty horrible. This is our y triple prime, and here is 4 times our y 1 prime. See, here's 4 times this plus 4 times this, and that is got to be equal to e to the x times cosine of 2x. So that means if we look at the cosine of 2x, e to the x cosine of 2x terms, we got negative 11a, we got minus 2b, and we also have positive 4a and a positive 8b e to the x cosine of 2x. So that means we got negative 7a plus 6b equal to 1. That's what's on this side. And the e to the x sine of 2x terms disappear. So that means 2a minus 11b plus 4b minus 8a, which turns out to be negative 6a minus 7b. That has to be 0. So we get the system negative 7a plus 6b equals 1, and negative 6a plus minus 7b equals 0. And I solved the system separately and got a equal to negative 7/85 and b equal to 6/85, and the solution to our equation is yc plus yp, which is c1 plus c2 cosine 2x plus c3 sine of 2x. That was our complementary solution, plus we found our a and we found our b, and those are just filled in here, and that's our this part of it is our particular solution. Oh, can't seem to include the minus sign, but, and that was
So very difficult.
yes, but it's finished.